Have you ever looked at the land around you and wondered what processes shape what you see? Perhaps you see mountains, valleys, rivers, or canyons. Do you know how long these geologic features have been there? How do you think they got there? What will they look like 10 years from now? How about 10,000 years from now? In thousands of years, do you think these features will still be there? Or will they have changed into something new? Process that shapes Earth's crust. Earth's outer layer, its crust, is dynamic. This means it is constantly moving and changing. Now, if you remember here, you have your convection currents. As the hot magma rises, it cools and falls, causing the Earth's layer, the Earth's crust, to constantly move and change. The geologic features you see around you may have been formed suddenly by forces from earthquakes or volcanic eruptions. However, most geologic features are shaped slowly over time by the natural processes of weathering, erosion, and deposition. These processes affect the land differently depending on the types of soil or rock found there. These processes can also be affected by other natural features such as vegetation, climate, and topography. The activity of humans and other animals can also cause change how weathering, erosion, and deposition affects Earth's crust. Now go ahead and take a note. We're going to highlight it in green. And I want you to remember green is significant to your activity sheet, everything that's highlighted in green. Weathering, erosion, and deposition. Many people mistakenly believe that weathering and erosion are the same, though they typically occur at the same time. Weathering and erosion are different processes. Weathering is the process by which rocks are broken down by mechanical, physical, or chemical means. The smaller bits of rock that result from weathering are called sediments. Now, remember, you're going to use whatever's highlighted in green for your activity sheet today. Mechanical weathering changes the shape and size of a rock without changing the rock's chemical composition. We're going to highlight that in green. The rock can be scraped, cracked, or broken, but the chemicals that compose it do not change. Chemical weathering breaks down rocks through chemical processes such as dissolving or oxidizing. If you look over here, oxidize means to react with oxygen. Chemical weathering changes a rock's chemical composition. In other words, a new kind of rock is formed. As a result of chemical weathering, a rock's state of matter, which is solid, liquid, or gas, may also change. However, this would be physical and not chemical. Now right here is an example of mechanical weathering. The rock is being weathered or broken down into sediments. Earth erosion is the process by which rocks, sediments, or bits of soil are carried away. Agents of erosion include flowing water, ice, wind, and gravity. An agent causes something to happen. As sediments are moved, they can scrape against other rocks, causing mechanical weathering at the same time as erosion. Because weathering and erosion can occur at the same time, rocks that are carried long distances by erosion tend to be more weathered, making them smaller and more rounder. Rocks that are carried shorter distances, particularly through gravity, tend to be larger, more angular pieces. Page 2. Eventually, sediments being carried by erosion stop moving and settle out in a new location. This process is called deposition. Sediments are generally deposited in horizontal layers, like you see right here. The older layers are on the bottom and the newer layers on top. Please draw here. So horizontal lines, layers, the older layers are on the bottom, the newer layers will be on top. Topography and satellites. Topography refers to the steepness or flatness of the land. This is also called relief. Topography includes features such as mountains, hills, cliffs, valleys, and depression. The processes of weathering and erosion and deposition can change the topography of an area over time. For example, winds and gravity can lower the elevations of mountains by breaking them down and carrying away their rocks. Flowing rivers and moving glaciers can also cut canyons into the ground. Scientists can track these changes in topography over time using satellite technology. Satellites are man-made instruments that are launched into space and that orbit Earth. Many satellites are equipped with powerful cameras. These cameras can photograph landforms and other features from space. This provides a large-scale view or topography of an area. which allows scientists to study major features and patterns in ways that would otherwise be impossible. Because satellites orbit Earth, they can photograph the same area every time they pass over it. This allows scientists to study the changes in topography that weathering and erosion and deposition can make over time. What do you think? Both photographs below were taken by a satellite. The photograph on the left right here shows China's Yellow River Delta in 1989. The photograph on the right here shows the same region in 2009. How did the region change between 1989 and 2009? Here's a hint. The brown areas you see here show land. The blue areas surrounding it show water. How might weathering, erosion, and deposition have caused these changes? So think right now, how might weathering, erosion, and deposition have caused these changes? Page 3. The patterns of contour lines on a topographic map reveal the shape of a land as viewed from above. This is called, remember highlighted in green, a bird's eye view. Contour lines are generally curved to follow the natural flow of the landscape. Contour lines that are very close together represent very steep areas, and if you remember from our water kit lab last Friday. This is because the elevation is changing drastically over a short horizontal distance. Contour lines that are farther apart represent gently sloping areas. This is because the elevation is changing less over a horizontal distance. The patterns formed by contour lines allow scientists to see the erosional features that shape the topography of a landscape. Here are some other ways contour lines can show topography. When contour lines form concentric circles, that is, one circle completely surrounds another circle, and you guys drew this the last Thursday on the Topas Locas lab and the water kit lab. They represent a hill or a mountain. This is because the elevation is changing all the way around the mountain. Depressions, such as a cave or the top of a volcano, are represented by circular contour lines with a small hash marks inside the circle. When contour lines cross a stream or a river, the contour lines are represented as V-shapes. These V-shapes point in the upstream direction of the stream or river. This is because rivers cut V-shaped valleys into Earth's crust. The contour lines point to the higher elevation from which the water is flowing. Unlike rivers, glaciers cut U-shaped valleys into Earth's crust. These valleys can also be seen in patterns of contour lines on a topographic map. Creating new topographic maps of an area can also allow scientists to compare changes in the land over time. Scientists can also examine the topography of an area and predict how weathering and erosion will affect the land over time. For example, tall, steep structures that stick out from the land are more likely to be weathered and eroded by wind or flowing water. Shallow, gently sloping areas are being shielded from wind and are less likely to be weathered and eroded. Look out. Contour lines get closer as the land gets steeper. Now, again, you guys were able to construct this during our two labs, Thursday and Friday. They can even appear to touch each other if an area has a vertical cliff. This is because the elevation is changing drastically with almost no change in the horizontal distance. However, please remember your contour line rules can never cross over each other. For example, if a 10-meter contour line crossed over a 20-meter contour line, the point where the lines would have an elevation of both 10 meters and 20 meters. That is impossible. Contour lines also cannot simply end in the middle of a topographic map. They either connect in a loop or run off the borders of a map. Now, after you're done with your reading, let's see, we have one more part. Career corner, surveyor. Remember what's highlighted in green is significant to your activity sheet. A surveyor is also known as a topographer. Is a person who studies landscapes. We're going to highlight that in green. Topographer is a person who studies landscapes in order to create topographic maps. Surveyors are very important when planning excavations, new buildings, or other projects for which knowledge of topography is needed. Surveyors use special instruments such as theodolites to gather data about a landscape. A theodolite can be used to measure both elevation or horizontal distance throughout an area. Modern theodolites are equipped with lasers that measure very precisely the distance to a particular point, as well as the elevation of that point. Right here, you see a surveyor that is using a theodolite. Surveyors also use compasses to determine the angle, north, south, east, west. From one point to the next, many theodolites have built-in compasses and record all of these data at once. Surveyors can then use data to create a topographic map. Now, go ahead and start.